explain you the design of this container. The purpose of this container is to collect all the ping-pong balls that drop each time the ball pass through the sensors. So there are two sensors, and each of them is just placed beside the pathway of the ball dropping. So sensors located here and here. The sensors are the proximity sensor. So the proximity sensor will sense each of the aluminum foil located on the top of the container. So the material that we use to create the container are cardboard and transparent sheet. Furthermore, we use hot glue gun to combine and attach all cardboard and the transparent sheet. So as we can see, we make two compartments which will be allocated with 4 ping-pong balls in each compartment. Then the transparent sheet purpose to enable us to see how many ping-pong balls are allocated in each compartment. So the related manufacturing process is the design of the container is related to class of material handling process such as scraps from the other process, collecting plastic pellets, existing manufacturing process and others. So the design of this container is quite simple but really reliable.
My name is Lian and I'm from group M03. Today I'll be explaining about the wiring process. Firstly, as you can see here, all the red wires here represent the positive terminal of the components. All the red wires are connected to the 24V power supply of the PLC. Firstly, we will be talking about the connection of the solenoid valve. The solenoid is connected to the interface circuit, which is then from the interface circuit is connected to the Raspberry Pi microcontroller. As you can see, the first solenoid valve is connected to GPIO pin 19, followed by the second, third and fourth solenoid which is connected to GPIO pin 13, 23 and 24 respectively. Next is the connection of the two relays. Just like the solenoid valve, the blue wire of the relay is connected to the interface circuit, and then from the interface circuit, it is connected to the Raspberry Pi. For relay A, is connected to GPIO pin 5 and for relay B is connected to GPIO pin 6. Next is the connection of the sensors. Taking sensor A, the blue wire is grounded, whereas the black wire is connected to resistor of 1.5 kilo ohm and 10 kilo ohm which is grounded. In between the two resistors, the node is connected to pin 20. Same for sensor B except that it is connected to GPIO pin 21. Next is the connection of the switches. Taking black switch, the black wire of the switch is connected to a 1 kilo ohm resistor which is grounded and is then connected to GPIO pin 17. For the red switch, it is connected to GPIO pin 27. Lastly is the connection of DHT22. The VDD is connected to GPIO pin 3V3 and the data is connected to GPIO pin 4, whereas the last leg is grounded. In between the VDD and data, a resistor of 10 kilo ohm is connected in between the two legs.
My name is Goh Wei Shing. Today I'm going to explain about the code that we use to program the system for our project. So we need to import tools libraries that needed for our project into our Raspberry Pi, as we can see above. Next, we need to set up the GPIO pin number for each service that we gonna use. So as an example, the black switch is connected to pin number 17, so we need to set up into black switch equal to 17, and others also set up like this. Next, we need to set up everything for the Raspberry Pi and also the service. So we need to set the mode, GPIO mode for the Raspberry Pi as BCN. And then for this tree is used for the DHT22 sensor. So we need to initiate GPIO for 5 GPIO and then set the pin number for the DHT22 as number 4. And then this trigger function is used to recruit the first reading, as the first reading detected by the DHT22 will be negative value. So we need to neglect it. Then we need to set up the service into input or output service. So as we can know that switch and the proximity sensor will be set up into input service and the relay and solenoid will output service. Next we will set up the initial condition. So relay will be the low initial condition and the solenoid will be in high initial condition. Low means that the relay is in off condition. Then high means that it's activated. So low is deactivated. Next, this code is used for the DHT22. So it's used to detect the humidity and temperature and display from the surrounding and display into our screen, display screen. The important part is we used to like arrange the sequence for the solenoid and when the proximity sensor is triggered. So when the black shift button is pressed, the process is start running. So we need to set out the number of balls equal to 0, start from 0, and it will be add out the number of balls equal to n. So the process is complete when the number of balls is collected at. So when the proximity sensor is sensed, so the conveyor will be stopped, then the solenoid will be run in the loop function as highlighted as this. So it will be low, high from top to the bottom valve. This part will be locked in twice because we have put in range of 2, so total up two numbers of 4 will be collected, and then another 2 numbers will be collected at the left proximity sensor. But then it will lock again twice for overall function, for overall this in order to collect overall 4 ping-pong balls here and another 4 ping-pong balls here. And we also include the emergency condition, which is the rest shift is pressed or immediately is larger than 75, the process will be stopped immediately. Next is the accept keyboard interrupt. The accept keyboard interrupt is used to switch off the system by using the short key in the keyboard. As we can press the control plus shift button, then the system will be stopped. And then we add on the GBL.cleanup is used to clean up everything that we have set up here. For example, GBL pins. Then the exit button is exit function is used to exit from Python. Thank you.